This tutorial will illustrate how to use flaw detection. First, open Full Configuration, Measurements, and then open a previously defined measurement to which you would like to add flaw detection. Under the tab Flaw Detection, you will find a selection for absolute, relative, or both. These indicate the reference point from which you will decide what is considered a flaw. Absolutes will use recipe specification settings for reference, and relative uses the dimension's own last reported value for reference. You may decide to run both filters simultaneously. If you select absolute, next you must select a threshold from which the flaw must break to be considered a flaw. With deviation from nominal, you can enter a numerical value for this threshold. With percent of nominal, you can select a percentage of the nominal value to be this threshold. For from specifications, the upper spec limit and the lower spec limit will be used as the threshold. If you select relative, your flaw threshold will be a calculated deviation from the last reported measurement value. With a dimension change, you can enter a numerical value for this deviation. With percent dimension change, you can select a percentage of the last reported value for this deviation. With the threshold designated, you will then need to decide the pattern of exceedance before it is finally reported as a flaw. This is done under flaw length. Unit choices are in scans, milliseconds, or units of length. Next, select a running window of data to analyze using the unit selected, such as 10 scans. Then select how much of this window needs to be exceeding the threshold before establishing a flaw condition, such as 4 out of these 10 scans. Lastly, you need to decide how much of good product needs to pass before it is no longer part of that initial flaw, such as 8 scans. Once the program sees 8 consecutive good scans, it will start looking for another flaw. For demonstration purposes, I'm going to use absolute, use from specifications, so it's obvious when you cross the threshold, and milliseconds, and I'm going to make a rather large flaw so we can count off the seconds and watch that flaw appear. And we can reset also after 4 seconds. Now, flaw averaging here at the bottom will average single scan data before reporting it to the above analysis. This should be set to 1 for most applications. Use location offset if the encoder value refers to a different scanner or location on the line. Enter the offset necessary to correct this scanner location. This completes the flaw definition procedures. Alternatively, you can enter flaw settings into a recipe. Any flaw settings in an active recipe will override all settings in measurement definitions here. To do this, open up recipes, open up your active recipe or the recipe to which you'd like to add flaw settings to. Click Flaw Settings, Add Flaw Settings, select your measurements, followed by the same screen you saw before. Define it here, and save it. Load your recipe, and those will be the active flaw settings. With the flaw settings in place, you now need to add the actions necessary to start and stop flaw detection. Click Add Action, browse for Flaw Detection On, name it appropriately, either act on all measurements or select the measurement you'd like to apply to. Make sure you have a good name for the counterpart. Now also, while you are in actions, there are other flaw actions that would be a good idea to go ahead and create, one of which is generate reports, which we will go ahead and do so now. So under generate report, you can act on all measurements as we did before, or select the measurement to which you'd like to have it applied to. Under the Flaw Report tab, you can choose to either save to disk or to print. If you save to disk, you can choose between comma, space, and tab delimited data. Also, you can choose if you'd like to see the header displayed as the first entry in the report. Under the More Report Options tab, you can choose to include the measurement names in the report or to generate a separate report for each measurement. And also you can have it clear the flaws when it generates a report. Also decide if you would like it to start or stop or remain unchanged. Next, under Auto File Name, select a good place to save it. Today I'm going to save it in C Data and then a folder with the date, followed by Flaw Report, followed by the time. Now with these actions in place, we need to choose a way to execute them. Today I will use buttons. Got 3 already defined here on the left side. And Flaw Report for the Flaw Report, Flaw Start for Flaw Start, Flaw Stop, Flaw Stop. Verify that they're correct. I also recommend having a visual flaw count. Use this using an SPC window. First, go into SPC plans and make sure that your selected measurement is in there. Then go to Window, New Window, SPC Data, select your measurement. I like to use the default fields, followed by the flaw count, the lump count, and the neck down count. The neck down and lump count will add together to equal the flaw count. Lumps are too big, neck downs are too small. I'll put them in the same column. Use the defaults for everything else. The nice thing about this window is you can see if flaw is already started or not. It's blue right now, which means it's already started. If you stop it, it turns gray. So I want it started. Then I can exceed a limit. And it took the full 2 seconds before it established a flaw. And notice that was a neck down. Next, I'm going to make a lump. Exceed it for 2 seconds. And there's our flaw. Thank you for watching. This has been Tutorials by Joel.